So here is another example of solving a literal equation, okay? And whenever we say a literal equation, we're meaning when you're asked to solve for a particular variable. So in this particular case, we're actually asked to solve for the variable c. Let's just say FOR, solve for the variable c. So in other words, get c by itself. So the technique here that you learn back from grade school when you learn how to add and subtract fractions, you try to, one technique is you can multiply by the least common denominator. When you solved not really grade school, but when you solved rational equations really in middle and high school, you can multiply each term, each one of these or terms, you can multiply those by the least common denominator of the expression. So if I were to ask you what was the least common denominator between A, W, and C, just to kind of spare a bunch of conversation, you could basically multiply these. So for example, let's say we had to do 1/2 plus 1/3, okay? And if I wanted to add these fractions, one way of getting the least common denominator would be by multiplying 2 and 3, and you could get 6. Then we could say something like 2 goes into 6 3 times. Take that 3 and multiply it by that 1, you get 3. 3 goes into 6 2 times, and then 2 times 1 is 2. And so that would be one way of solving that fraction, of getting the least common denominator. So likewise, with A, W, and C being all different variables, the way that I can get the least common denominator for that problem is by multiplying A, W, and C, which would be A, W, C. So if I multiply each one of these by A, W, C, multiply this by A, W, C, multiply this by A, W, C, well, what happens? So the A's would cancel. Then that will leave me with WC times 1. That's WC. Here, the W's would cancel, leaving me with AC times 1 is AC. And then here, the C's would cancel, leaving me with AW. Now, keep in mind, we're trying to solve for C. So this is now a technique where if you look at this side over here and ask yourself, what's the greatest common factor? You see both of these terms have a C in common, so I can pull the C out. And in doing so, if I pull the C out, I'm left with W plus A, and that's equal to AW. Remember, ultimately, we're trying to solve this for C. So how do I get C by itself? Well, this expression on the left is C times W plus A. So the way I would get rid of W plus A is by dividing. We do the opposite operation on both sides. So W plus A cancels out, and C will be AW all over W plus A.